All right, welcome back to the second part of Organic Innovation Days, the afternoon session, in which we will focus on the animal production. I hope you have enjoyed your lunch break. I did, and I'm looking forward to the next part. The first speaker will be Carmen Manuelian from the University of Padova in Italy, and she's based in our part of the Organic Plus project, and she will speak about antibiotics or alternatives to antibiotics. So please, Carmen, the floor is yours.
Thank you. Do you see the presentation well?
Yes, perfect.
Okay, so I'm going to present some of the studies that we run within the Organic Plus. And the idea was to try to find alternative to reduce the use of antibiotics in the organic production. So as you may know, the organic production regulation forbids the use of allopathic treatments as prophylactic. And it says also that vitamins and provitamins should be of natural origin. So the aim of the following studies that I'm going to show you is to try different essential oils, plant products to improve the immune system as an alternative to reduce the need of using antibiotics in the animal production. So here I'm going to show you 4 studies. The first one is an in vitro evaluation of the antibacterial effect of essential oils, natural identical compounds, and plant extracts based on the minimum inhibitory concentration. And also we ran some cytotoxicity tests of the essential oils to see how when they can be damaging the epithelium cells. Then I will move to 3 studies that we did on the animals in vivo. The first one is this, the Scutellaria baicalensis, that is an herb to improve the beef performance. Then I will move to the one where we use different herbs to improve the dairy cattle immune system, milk production and milk quality. And I will finish with a study that we ran in organic broilers by using plant feed additive as well. So moving to the in vitro study, we evaluated 8 essential oils that you can see here, different essential oils. And remember that here we are looking to the minimal inhibition concentration, and we tested that against 4 bacteria, gram negative and gram positive. That's why here you have the 4 graphs. In this case, you just need to remember that what we need is to find the lowest amount that we need of each essential oil. So you will see that for the 4 bacteria, it was the oregano essential oils, the one that showed the best results. But also we see a good results with the tea tree and the thymus. Then we also evaluated the natural identical compounds. Here we have in this table the same bacteria that I showed you earlier. And in this other side of the slide, you have the different identical compounds that we tested. So the best result was obtained for the Staphylococcus aureus using the cinnamic haldehyde. You see that the amount is lower, but we also have good results with carvacrol and thymol, because you can see that for the other bacteria that we tested, we also obtain, we need a lower amount that for the terpinol or the menthol. But our question was, okay, but how high could be the concentration of these compounds without damaging the epithelial of the intestine. For that, we ran the cytotoxicity test of the essential oils. So in this case, we want to see the viability of the intestinal cells when we give to the animals these products. In particular, I'm going to show you here the results related to the oregano, the cinnamon, and the rosemary. So the first column, the one in red, is representing the control plate. In this case, we did not add any essential oils, and then we increased the concentration of each essential oil to see when the cells were not alive. You can see here that for rosemary, we can arrive to a higher dose before killing the cells. But if we look to the cinnamon, we see that with a lower concentration, we start killing the cells. So that means that even if oregano or cinnamon are a good alternative to the antibacterial, they have an antibacterial effect, we have to be careful with the dose that we are administering to the animals, because it could be also damaging the epithelial cell. Now I'm going to move to the in vivo studies. So the first one is related to the use of Scutellaria bicalensis, that is an herb that is used in the Chinese medicine, and we tested in beef. So the literature said that this herb have anti-inflammatory and antioxidant properties, but most studies have been focused on tested it on monogastrics, so pigs and poultry, and not ruminants. So we decided to test this product in 143 cheroles that were in 12 pens and 11 of animals per pen, and half of the animals received the product that was the Scutellaria. So they received 20 grams per animal a day, and the study lasted 4 months. That includes the fattening and the finishing period of the animals. And we finished the study when we put the animals in the slaughterhouse. So here we are going to look to some results. You have in this part of the slide the traits that we are going to speak about, and the group here will be is the control group. So they did not receive any supplement, and here the ones that received the Scutellaria bicalensis. So you can see that for the intake, we did not see any differences between both groups. Then if we look to the body weight at the slaughter, the carcass yield, or the food conversion ration, we also did not see differences between both groups. We also took blood samples to evaluate the alpha tocopherol plasmatic concentration, that would be the vitamin E, that is a natural antioxidant. And once again, we did not find differences between the both groups. We also evaluate the total protein as a marker of the protein metabolism, the glucose as a marker of the energy, and the triglycerides as a marker of the fat metabolism. You can see here again that the two groups didn't differ between them. So to conclude this study, we see that the addition of Scutellaria bicalensis did not impair the feed intake or the digestibility, which is a good thing, but and it also did not have any detrimental or beneficial effect on the growth performance. the plasmatic level of vitamin E was similar between both groups as well, and also the metabolic profile. So we were thinking, okay, what we can do next if we want to continue evaluating these kind of products. And we thought that maybe it could be interesting to test different doses, because here we only tested one. And also it will be really interesting to evaluate the meat quality. So at the beginning, this was our idea, but as you know, in 2020, we have the lockdown due to COVID, and this study we finished, we arrived to the slaughterhouse when they closed our access. So it could be interesting to evaluate if the meat of the animals receiving the Scutellaria have some differences between both groups. So now we are moving to the study where we use a mix of herbs in dairy cattle. Once again, these herbs have anti-inflammatory, antioxidant properties based on the literature, and they have been tested in monogastric, but not in ruminants. So here we decide to test these products with Holstein Friesian, 163 animals that were enrolled after calving. And we give to half of the animals 3 boluses containing this mix of herbs and on 30 days in milk. We also select the animals based on the somatic cell count that they had in the present lactation. So we select animals with a high somatic cell count and a low somatic cell count to try to improve their immune system. We took several milk samples at different times, so 30 days in milk, 70 and 100. And we also took blood samples at 30 days in milk, and we evaluated some fertility traits. And this table shows the results of the model that we used to statistically analyze the parameters. So here you have the main effects that would be the treatment. So if the animals were receiving the bolus with the herbs or the control group, the sampling time, because we collect samples at different times. Also the calving season when the animals calve, and the group of somatic cells, as I explained you earlier. So here you have the p-value for each one of the effects, for each one of the parameters of milk yield, energy corrected milk, or fat, protein, casein, lactose, concentration, somatic cell count, and pH. The important one was the treatment, because it is referring to the animals that were receiving the herbs. But you can see here that we did not find any differences between groups. Where we find differences was when looking to the sampling time or to the calving season, what was expected, because you know it works like that. Then we also took blood sample at 30 days in milk. And in this case, the model only considered the treatment and the group of somatic cells. In this case, you can see that for alpha tocopherol, that was the vitamin E, we can, the p-value indicates a tendency. That means in this case that the animals receiving the herbs have a higher vitamin E concentration in the blood. But we did not see any other differences in the blood parameters, or even we did not see differences when we look to the fertility traits, that is days to the first insemination, or days open, or the days of calving to conception. So in conclusion, we did not see any detrimental and beneficial impact on the milk production and composition. We did not see either any effect on the metabolic profile or fertility traits, but we saw a slightly greater plasmatic vitamin E levels in the treated animals. So next steps that we will like to think of is to test different doses, but also maybe to test this product with cows that really have a high somatic cell count in the current lactation, or that they have fertility problems or are under stress conditions. So moving to the last study is the one related to the use of plant feed additive in broilers. These the ones that we selected have anti-inflammatory and antioxidant properties, and they have been tested previously in monogastrics. But the difference with our study is that we decide to substitute the vitamin E with the bark extract or the green tea and grape extract. For that, we used 252 broilers of Ross line, 28 animals per box and 9 boxes. And here I'm going to show you the results for the 42 days of the trial. Looking for the results, here you have the traits that we evaluated. This one is the vitamin E group, so the control. This other column is referring to the green tea and green extract, the green tea and the grape extract group. And the last column is referring to the bark extract. So you can see that the feed gain ratio was similar between the group receiving the vitamin E and the bark extract, and which is quite interesting. The feed efficiency in this case was also best for the bark extract, and it did not differ to the vitamin E group. We also evaluated the plasmatic vitamin E. In this case, as we expected, the group of receiving the vitamin E was the one with the highest amount of plasmatic vitamin E. We also select to show you the creatinine concentration as a marker of the kidney metabolism. And you can see that the best results were obtained for the grape extract compared to the vitamin E. But what is also interesting is that the bark extract has the similar level than the vitamin E. So it means that we can use also that to replace the vitamin E. And then we also have here the ALT, which is a marker for the hepatic, for the liver. In this case, best results were obtained with the bark extract, but you can see that they did not differ with the green tea and the grape extract. So to conclude, our study demonstrates that we can successfully substitute the vitamin E with the plant extract. The better feed conversion was obtained with the bark extract. The green tea and grape extract seems to have a protective effect on the kidneys, and the bark extract seems to have a protective effect on the liver. So to summarize all the results that we observed in these 4 trials that I show you, because there is a high interest to find an alternative to improve the immune system, you have seen that in broilers we were able to use plant plant feed additives to substitute the vitamin E. The problem with the ruminants could be the rumen microbiota on the degradation of the plant feeds. And maybe it's that because that's why there are very few studies also in ruminants, because it's difficult to find good results on that. So it's difficult to have scientific evidences in healthy animals. So maybe it could be interesting to test these products in animals that are under stress or with controlled infections to see if we can improve their status. So thank you for your attention.
Thanks a lot, Carmen, for this presentation. Good insights on replacing antibiotics, but also already looking for alternatives for vitamins, which we will discuss also later in this session. I will immediately move to the next presentation because we're a little bit over the time. And we will continue with Michael Walkenhorst from FiBL Switzerland, researcher from the RELAX project.
Yeah, thank you very much. Good afternoon all together. I will show you some outcomes of our RELAX project and with a specific emphasis on dairy cows mastitis. So mastitis is for sure one of the most important problems in dairy cows' health, beside fertility maybe and metabolic disorders for sure. And in organic agriculture, it is the most important cause for an antibiotic treatment of dairy cows. We have to deal with a broad spectrum of mainly bacterial pathogens, which are causing as well clinical as subclinical mastitis. And last but not least, we have a big financial losses from discarded milk and from penalties for a high somatic cell count. Well, the main objectives of our issue in this surrounding is the development of solutions for a replacement of antibiotics which are used in organic livestock production on the example of mastitis. And we choose two ways to go through there. That is animal health and welfare planning protocol, a protocol which was developed already in another European project. And we tried to use natural components, mainly essential oils. These adapted strategies will be validated. We try to validate them on farm. So a few words with regard to the animal health and welfare planning approach. We need on the one hand data, so milk recording data or treatment data. We have on-farm data, and we use the Assure Well protocol, which is mainly addressed to the animal welfare. And we used as intervention method, farmer stable schools in a 2 years intervention. And we have in this project intervention as well as control farms. So we are in this part of the project on the farm level. The animal health and welfare planning is not a plan, but a planning. A lot of farms, dairy farms in Europe have animal health plans, but we want to focus on the process of planning. And this means it is a continuous development and improvement. And you see it here a little bit. We have a strategy which is based on an assessment of measurable parameters. Then we have a health planning action, and we have evaluation again. And we have to incorporate for sure health promotion and all aspects of disease handling. We have participating farms from 3 European countries, so from France, UK, and Spain. And we used this method of farmer stable schools, which is a peer-to-peer advisory measurement to, in our case, reduce antibiotic inputs. And it was initially tested in this core organic project Aniplan some years ago. And you see here some farmers intensively discussing peer-to-peer specific problems of the farm. The farmer stable schools are co-development advisory methods, and you take together normally 5 to 7 farms which meet on a host farm. And beforehand, the host farmer describes on the one hand with a little farm visit for about half an hour, a success case. This is, I think, a very important point to motivate also farmers to show also success cases of their farm, and then has 2 precise health questions which he or she wants to submit to the other farmers which are on the farm on the same day. They got data beforehand from the advisor, and they discuss these specific farm-specific health questions on the farm. They had discussions then, and an important point is that each individual farmer brings in his input. So the moderator has to be aware of inputs from each individual farmer which visits the host farm. And in the end, the farmer gives his decision, which is then documented for a later analysis by the advisor. Well, this was the plan. We want to have several farms visited, and this fits very well in 2018 and up to the mid of 2019. And then the reality was that also in our project, the pandemic situation was a real trouble also in getting into the time plan, and this was then not possible as we hoped. However, we had as a first conclusion the RELAX animal health and welfare planning protocol established and introduced in 2 new countries, so France and Spain, and we had re-evaluated it in another country, Great Britain, which was also part of the ANIPLAN project. We constructed and wrote a practice abstract, which is online freely available, and all the feedbacks of the farmer stable school participating farmers were very positive. The evaluation of the intervention was, well, let me say, modified by the COVID conditions and is still ongoing, but we were very hopeful that we have final outcomes during the next, let me say, 3 to 4 months. Then we want, in the same project with a specific method, we want to assess assess essential oils to control clinical mastitis. The clinical mastitis cases should be light or moderate mastitis cases, so no very hard and highly acute mastitis cases. And the idea of this was a refinement of farmers' experience. As maybe some of you know, is essential oils are widely used by French farmers, and we want to go out with them into 2 other countries. They are used traditionally by French farmers due to their antibacterial and also due to their antimicrobial and anti-inflammatory effects. And for sure, as it is always with traditional use of products, the efficacy and the safety was not being systematically quantified beforehand. So what was the main choice of the essential oils? Well, I already said it, the farmer experience was the first choice. So we had a list of 10 essential oils, and then based on this list, we chose due to several laboratory analysis the main essential oils we worked with then in the end. These laboratory analyses were on the one hand the aromatogram to quantify the assumed effects of the essential oils to control mastitis. I think this is mainly the same method as Carmen reported already. And we used some important mastitis pathogens to control the use of the essential oils. But we also go with tissue cultures with mammalian epithelial cells tests, and to look how is the effect of the essential oils on the mammalian epithelial cells. And we did a chromatogram with regard to chemical characterization of the essential oils, as we normally have a mixture of a very broad spectrum of chemicals within each individual essential oils. And then there was also some bibliographic work with regarding to regulatory issues. Well, these were the 10 essential oils I pointed out already. Finally, based on all these experimental in vitro trials, Lycea citrata and Origanum vulgaris, or Oregon, were the both essential oils which we are going for the next trials then. What is for surely important is the assessment all around milk quality and safety. And from treated cows, we sampled milk samples to detect markers of the essential oils in the milk. So, for example, terpenes or aromatic or other aromatic compounds. We measured the potential impacts of the essential oils on the acidification, which is a very important point with regard to cheese production. We measured the potential impacts of essential oils on the sensory properties of the milk, which is, well, as you all know, essential oils are of sensory properties, and no one wants to have them directly into the milk. And what is also a very important point is to verify the absence of reaction in the test for detection of the normal used test of detection of antibiotic residues, so the Delvo test. Well, the results with regard of the essential oils is the detected markers of the essential oils contained in the milk. So the terpenes and the aromatic compounds are in the limit of detection, range. So we don't see any important point as residues in the milk. The essential oils do not affect the acidification. Some slight delay of acidification after one essential oil treatment, but it is not dramatically. We have no difference, which is also a positive outcome, no difference of sensory quality between the treated milk and the control. And we have a complete absence of any reaction in the test for detection of antibiotic residues. So the Delvo test is always negative if you treat cows with these both essential oils. Then we try to assess the efficiency of essential oils on farm validation. So the treatment was compared, the essential oil treatment was compared with the antibiotic treatment to treat these light to moderate clinical mastitis cases. And we developed, therefore, a protocol of a relaxed mastitis treatment trial, which I think in my eyes is a good protocol even to go further in mastitis research with natural substances in the future. Just to show you what we did, because we have always in keeping in mind that we have for sure also animal welfare aspects to include into this protocol. So we have the clinical mastitis case, and we randomly distributed the cases into an antibiotic treatment and an essential oil treatment, and we got back on the cows 2 days on the next day. Well, the farmers controlled and gave feedback, And when the clinical mastitis signs are on the second day fine to moderate, we keep the essential oil treatment. In the other case, we put it to the other group, so to the antibiotic treatment group. The same is done again on day 5. And when it is still fine, then we keep the essential oil treatment. And the clinical mastitis signs will be measured then again on day 7. And these are also the days we get samples for milk quality control here. And on day 28, we get again milk samples for the somatic cell count, clinical mastitis signs, and also other quarters. So what we want to measure to get information with regard to the efficiency is the clinical healing, so observing the clinical signs. So we measured the body temperature, any blood or any other things in the milk, the abnormal milk we measured for sure too. And we looked at if in other clinical signs of the udder, so the heat of the udder, the redness or edema or hardness, so all the normal clinical signs of the mastitis of the udder. So then we go to see what is the clinical, the cytological healing based on milk recording data, which we had regularly from all the cows about 2 months after the treatment. And the bacteriological healing, we had a look at 3 weeks after the end of the treatment. Unfortunately, we had such a low number of treated mastitis cases, which was also for at least partly due to the COVID situation, that we cannot have a final conclusion regarding the efficacy of the essential oil treatment. The first idea is that we have not a big difference between the antibiotic treatment and the essential oil treatment, but it is really of a very low power because of the very low cases. But we have a test protocol now. This is established and it was introduced into 3 European countries, and for sure could be used in future studies, especially with regard to natural compounds used to treat mastitis. So coming to the overall conclusions, this outcome of this part of the RELAX project was that we could say the animal health and welfare protocol is adapted. It is always good if you have a running protocol, a function protocol, as we had from the Aniplan project, to re-evaluate it some years later, about 10 years later, meanwhile. And it is adapted to the recent on-farm conditions, and it is newly introduced in 2 European countries. We have a praxis abstract here. And we have established the farmer stable schools as peer-to-peer advisory, which is really a success case in my eyes. We have a lot of positive feedbacks. And we have, last but not least, a protocol to test the replacement of antibiotics in mastitis control under on-farm conditions. So hopefully I'm in time, and I would like to thank you for your attention.
Thanks a lot, Michael. You were in time and you were also very clear. I have one question for you that comes from Berit. It's a very straightforward question, but still was not completely clear for the audience. How are the essential oils applied? Are they applied to the udder or is it intake?
Yep, absolutely correct. Thank you for the question. I lost it off, obviously. Well, it was applied on the skin of the udder. So outside, mixed with some sunflower oil.
Okay, good that you have clarified that. Then we go to the next session that will be on Anthelmintics, so to treat parasitic worms. And this first presentation will be by Spiridoula. Oh, it's a difficult name. I'm still not used to it. Spiridoula Athanasiadou from the Scotland Rural College. And she's part of the RELAX project.
Thanks very much, Bram. I'm just going to share my screen. I hope you can see my screen okay?
Yes, perfect.
Great. So I'm going to present some of the data we accumulated in the work we did on replacement of Anthelmintics in small ruminant production. This is a collaboration of a lot of RELAX partners from various European countries. So helminthiosis is a parasitic disease, and it's one of the biggest health challenges for small ruminants. Gastrointestinal nematodes in particular are very important in terms of economic value because they cause subclinical disease. So abomasal species such as T. circumcincta and Amoncus contortus, or intestinal species such as Stivostrongylus colubriformis and Nematodaris batus have all been associated with subclinical parasitic gastroenteritis. And these result in penalties in weight gain, milk production penalties, wool growth reduction, and of course, overall the carcass quality is reduced. The losses affect more than 50% of farms globally, and the prevalence of this parasite is almost 100%. So pretty much every farm, small ruminant farm, has these parasites present. So traditionally, of course, gastrointestinal parasite control is done with Anthelmintics. However, for organic farming is not relevant because their use is regulated. Well, it is relevant, of course, but their use is strictly regulated. And also is an issue for conventional farming because there is a rise in Anthelmintic resistance. And under this big umbrella, we're searching for alternatives, which include establishing new grazing strategies to reduce their transmission, optimize the nutrition of animals, introduce bioactive grazing, also breeding for parasite resistance, etc. So a variety of different options are being looked at in terms of alternatives. I'll give you a little bit of a review of how the gastrointestinal nematode life cycle is. So the adult worms are inside the sheep, and the eggs are excreted in the feces of the animals. And then the eggs are developing into first stage larvae, and then second stage larvae, and then third stage larvae, which are ingested by the sheep. And then the adults are developing in the stomach, and that's how the life cycle is complete. So there are two, if you want, different stages of the life cycle, and one is the parasitic, which is effectively what happens in the animal from the ingestion of the infective larvae to the excretion of the eggs in the feces. And then, of course, we have the free living, which is what happens in the environment. So there are two ways of looking of how we can improve parasite control in animals. And one is to reduce gastrointestinal nematodes in the sheep, and the other is to reduce it on pasture. And the two alternatives we'll be looking in RELAX. We have been looking in RELAX targets. One of them targets what happens inside the sheep, and the other one targets what happens on pasture. And I will come to more detail about that in a minute. So the first objective we wanted to look in RELAX was to get an overview of the current use of and the need for Anthelmintics in organic livestock production in Europe, the same way as was previously presented for other works. And to do that, we decided to engage organic inspectors, European organic inspectors, because they had access to multiple farms, and we were hoping that this way the representation of presented basically by the inspectors is going to be more representative, the values we were getting. And we asked them effectively two questions. we asked them to quantify the proportion of farmers that have included anthelmintics in their health plans. And these are the plans that the farmers have to make every year with their inspectors, where they try and calculate the prevalence of parasites and the risk of disease, basically, to include anthelmintic treatments in their plans. And the second thing we asked the inspector is to quantify the proportion of the farmers that included anthelmintics as individual requests. So in addition to the health plans, when they had multiple challenge, if you want, and what they already had included in the health plans for parasite control was not adequate. So it was a very simple survey just to get answer to these two questions. And the survey was translated and disseminated across Europe. And we received responses from 139 inspectors from across Europe. They were representing 16 European countries, and they were covering, or they were responsible for, more than 17,000 organic livestock farms in Europe. And I would like to show you this image, which shows effectively the percentage of farmers that included anthelmintics either on their health plans, and these are the blue columns, or as individual requests, and these are the orange columns. Basically, what we want to see, what jumps out from this figure is the large variation in approach in the different countries. You see some countries had really pretty much all the farmers were asking for anthelmintics to be included in their health plans. Others, pretty much none of the farmers included it in the health plans. Quite a few of them asked for additional individual requests of anthelmintics, meaning that either they hadn't calculated the risk properly, or the risk was actually much higher than thought for that particular year. But what it would be useful to remember is that there is a lot of variation. So different countries are dealing with the anthelmintic use in a very different way in Europe. We took the data we collected from the survey, and together with some, if you want, data from the literature, we tried to extrapolate and do some calculations to see how much anthelmintics is actually entering the organic systems. And we calculated that 0.86 treatments per animal per year was entering the organic system, so less than 1 per animal per year, which is substantially lower compared to what goes in for the conventional systems. And if we try to see how much anthelmintics, excuse me, is entering the European organic systems in total, that's about 45.5 million doses of anthelmintics per year is entering the organic systems. Obviously, this is based on assumptions, but it's a rough calculation on what we believe is entering the organic systems of production in terms of anthelmintics. So that was the first objective, to see where we are in terms of use of anthelmintics in organic systems. And then the second objective is to start looking at the alternatives. So the first thing we wanted to do is quantify the anthelmintic properties of bioactive plants. And in this case, the bioactive plant we used as a model plant, if you want, is heather. Now, heather is a very popular plant up the hills, particularly in the north of Europe, but also in hilly southern areas. And we wanted to take samples from different countries around Europe to do a comparative analysis of the heather profile. We selected samples from 5 European countries, including Scotland, Switzerland, Norway, Germany, and Spain. We collected samples over 2 seasons to try and see whether seasonal variation was a player in terms of efficacy. And 2 different gastrointestinal parasite species were tested, one abomasal and one intestinal species. So heather is a plant that is rich in certain plant compounds that have been associated with anthelmintic properties. And this is what we were trying to identify in this study. So we showed that the efficacy of the different heather samples was again variable in different countries. From this example here, we did quite a few of in vitro tests. But this is from the egg hatch testing, and we showed that the heather that was from the UK and Spain appeared to have more efficacy against the eggs of parasites compared to Norway, for example. But again, the important thing to remember is that there is variation across the different countries of heather. All these heathers were treated exactly the same way, and the extraction process, it was exactly the same in the different samples. There was also variation in the efficacy in terms of the parasite species, where the efficacy was higher against the abomasal parasite compared to the intestinal parasite. And when we're looking at the seasonal effect, again, there was a variation with the samples collected in spring appearing to be more efficacious against parasites in all countries. So what this table shows is the LD50 of the extracts against the intestinal nematodes in this case. And basically, the lower the value, the more active the compound. So you see in Germany, for example, the spring sample is more active, in Norway as well, the UK sample the same, Switzerland the same, and Spain the same. So spring samples were more active against worms compared to the winter samples. And then the third objective of our work was to see whether the combined use of a biocontrol agent and a bioactive forage can reduce parasites in the small ruminants. So here in this work, we brought together two different alternatives. If you remember from the figure I showed before, heather is the one that is responsible for reducing parasites burden inside the animal. So heather is the bioactive forage, but then we also brought the Daddingtonian flagrans, which is the biocontrol agent. This is a globally distributed nematophagous fungi, and what it does, it effectively kills the larvae outside in the environment, the infected larvae. So this is the second step of alternative to target what happens outside the animal, what happens in the environment. We did a couple of these experimental studies with sheep, one in Switzerland and one in Scotland, and the results were consistent that when animals were eating heather, they reduced their fecal egg counts. You see that on the left, on the figure on the left-hand side here. On the y-axis is the eggs per gram feces, and on the x-axis is days into trial. And during the period that heather was fed in these animals, they reduced their fecal egg count, but also the total egg output was reduced. If you see the figure on the right-hand side, we also calculated daily egg output because we thought heather may interfere with changes in intake. So we wanted to make sure that we were taking this out of the equation, and heather consumption reduced the amount of eggs that were excreted daily by the sheep that were feeding on heather. So consistent in both studies we did. And this is a figure that shows the larval recovery in the treatments where the fungi was added. When the fungi were added in the diets of animals, indeed, the amount of larvae that were recovered from the feces were significantly lower compared to the control animals where they were not fed the fungi. So what we have concluded so far, and we're still trying to finalize the analysis of all the two animal experiments, but heather extracts varied in their anthelmintic efficacy. They varied in terms of the country of origin and the season, of course, and the different type of parasite that were tested against. Again, the nematode species showed variable susceptibility to heather efficacy, and I think that's interesting, and we need to try and understand why this may be the case. The combined use of the biocontrol, which is the fungus, and the bioactive agent may offer additional benefits for parasite control. There were certainly no sign of any antagonistic or any negative effects from one agent to the other. And the next step we want to do is to associate the efficacy of the extracts with the plant secondary metabolites that are in heather, and see how we can make some conclusions in terms of which ones may be the active compounds. Because at the end of the day, heather was used in Relax, but it is used as a model bioactive forage, and the principles of use should be the same for other plants as well, because heather is not present everywhere. So that's all I want to say. Thank you for the attention, and these are the collaborators for this part of the Relax. Thanks, Brian.
Thanks a lot, Spiridoula, for this insightful presentation on combating nematodes at the 2 level in the sheep, in the animal, and the environment. We will move immediately to the next speaker, that is Tove Serup from SEGES, that's the Agriculture Knowledge Innovation Center in Denmark, and she's part of the Organic Plus project. So,
thank you.
Tove, yeah, I think it works, yeah.
Thank you. And I'm going to talk about our study to avoid intestinal worms in pigs, and also I will present a little bit of results from my Organic Plus colleague Berit Blomstrand concerning lambs, but first about the pigs. Thank you. Intestinal worms occur quite often and is assumed to cause a low animal welfare. Sows build up immunity, but the piglets pick up eggs from the feces, and the worms develop easily. Veterinarian treatment is connected with the risk that resistance will develop. And besides these things, it takes time to administrate the veterinarian product. Prescriptions, analysis, and management of logbook and storage and destructions of leftover. So this is the reason it was decided to run a farm test to find out if Artemisia is an alternative to traditional medical treatment of intestinal worms in piglets. And the worm we focus on was Ascaris. We made a farm test design, looks like this. 80 pigs in 3 groups. Group 1, no treatment. Group 2, treatment with traditional deworming. The product is named Pigfen. And the 3rd group, treatment with Artemisia. And this was repeated 3 times with intervals of 3 weeks during spring this year. We analyzed when the, maybe I better tell about the management of the piglets as an introduction. The piglets are born outside in huts and are weaned at 10 weeks, where they weigh approximately 30 kilos. After 10 weeks in the grass pen, they are moved to a deep litter stable, where they are from 30 kilos to 60 kilos. It takes around 5 weeks. Treatment was given 5 to 7 days after weaning, and Artemisia was given with 10 grams per pigs. Artemisia is extremely bitter. So, and it's amazing that the piglets eat it well, but they did. So that's not a problem. Yes, thank you. We had a lot of results, and here I'll just show a minor part as examples because they are very much like each other, the all of them. Actually, the group with no treatment had only low or modified occurrence of intestinal worms egg. And the next group, thank you. The veterinarian product pig fin, that's the same, only modified or low occurrence. And the one with Artismeria, thank you. It was low and modified. In general, the incidence of worm eggs was low in all our results. Pig fin had a good effect, but when it comes to calculation, there's not enough difference between the treatment to be able to highlight one over another. So besides counting intestinal worm eggs, we also followed the growth performance and found that repetition 3 looks very interesting. It had a high daily growth performance. And was it because of the Artismeria? Unfortunately, no. But when we studied the situation, we found that group 1 and 2, please back, one back. They were from pens that have been used almost a year, and repetition 3 was piglets from a pen that was completely clean. So this shows that the grassing strategy is very important for the general health and for the daily gain. One of the speeches, I guess it was the first one, also mentioned grassing strategy. A difference of approximately 200 grams per day, that's interesting. And this is also what the farmers tell us. We have more and more farmers who adapt a new grassing strategy where they offer a new pen for every litter. And they have very good success with this. The only bad thing to say about this is that it takes a lot of work. Yes. And now to the next one. This is the conclusion. It was reminded that it was only a small farm test, but we couldn't calculate that there was a difference that could find that one was better than the other. On the other hand, the result shows that the piglets had intestinal worm eggs, and that the risk for developing worms are real. Reputation 1 and 2, the piglets came from pens that have been used almost a year. Opposite reputation 3, where the pigs came from a clean pen. This confirmed the experience from practice that it's important to have a high level of hygiene. Yes, thank you. And now I'll tell, no, sorry, we also have to discuss, yes, why we got this result. Was it the next one, please? Why did the artismetia not show a convincing effect? Was it because it does not have any effect? Or should we try to work with the doses? 10 grams per pig is not very much, but it was the recommendation from the company that produced it. Yes, thank you. And maybe also the period should be extended. I noticed that some of the previous speaker had a far longer treatment period. Thank you. Thanks for the attention for the piglets part and for the foundation for the work. And now I'll tell about the Blomstrand's lamps. If you could find these as the next one.
Sorry, Tove, these are the only slides that I had. Is there a second part of the slides?
Okay. Then there's happened a mistake. I'm sorry about that. But I think we don't have time.
Maybe you can do it without the slides?
We can have the break now, and then we start after the break. How many slides are it?
3 or 4, not
okay,
very
so,
much.
Howard, if that would be fine with you, we allow Tove to present her slides just after the break, and then we continue with Howard. Okay. There was one question I think that we got from you. No, I can't find it now at the moment. So then we just start with the break, and then we are back at 3:30.
Thank you.
And then you have time to find your slides.
Yeah, thank you.